Okay, so we are back. We have each of these different data sets that we created in the last video. Now what we have to do is we have to create a kernel density analysis. So the kernel density analysis is looking at over this moving window, this area of influence. Now something like this is very useful if you are trying to figure out some sort of static way of looking at what is the likely density. Now, in this particular case, this is extra useful for birds because birds will have a range over which they act. And so in this particular case, that makes this extra useful. So for this, what we're going to do is we are going to head to the analysis. We're going to head to our toolbox here, and we are going to find our kernel density. So our kernel density is under our spatial analyst toolbox. This is where many of the tools that are useful in ArcGIS end up residing for different overlays, raster analysis, and the like. So this is in the geospatial statistics though, so under that spatial analyst one. Now you can see here that you have input, point, or polygon features. We are going to use the point features, but you can do this for lines as well. So if you wanted to do something like the density of hurricane tracks, you are able to do that in this particular thing. The population field is if it happens to have some sort of value or some sort of weighting that is attached to it. So if there isn't this, then what it'll do is it will just count each feature as one. But if, let's say, there was a larger area of influence for something, right? So instead of having this as, let's say, a count of something, maybe this was pollution, and you wanted to instead deal with the level of pollution or the density of pollution, each one of those could be done in this particular case. The other thing that could be done is if you had categorical things like the hurricane level, right? So category 5 or category 4 has more weight than maybe a tropical storm. This could also be used in this population field. Now, in our case, we don't have that. We are going to instead just do each one of these. We are going to have no field in this case, and then same thing, we are going to give this a useful name. So in this case, we're going to call it the Grimophores. Now, if I do this, right, so I can have this output cell size. This output cell size is how big each raster cell is, right? And so this can get you into more or less useful things. Also, if there's a certain area that you know something acts over, you can add this to your search radius. So I'm just going to leave it as a default for now so that you can see what this is going to look like, and then we're going to go from there. So once I do this, and I'm going to uncheck my points just so that you can see this. So in this case, you can see that there are some areas where this thing is acting over, right? And we have one hotspot kind of in this Texas area. Now, if I zoom in, what you will see is that you can very clearly see each one of those boxes, right? And so this becomes a little bit of a finding the Goldilocks, which one is going to be the best bet. So if I increase this size, for example, so maybe I put it to 0.1 and I run that, I'm just going to write it over just so that you can see this. So if I do that, then each one of these ends up being a little bit bigger, right? So now this becomes a little bit more pixelated. This is far less resolved. I do have this little point here. If I increase it even further, I go to 1. This should, again, order of magnitude, just have one value over on this side. And you will see, yes, we just have this 1 pixel, this 1 degree by 1 degree pixel over here. So it is a bit of a Goldilocks effect, right? So in this particular case, I'm going to set mine to 0.01. You can always change this and run it at different levels, but this just resolves it a little bit nicer. You can see the gradient a little bit better, and you don't have the same level of pixelation that you had before, right? So these kind of look a little bit more like this kernel, like this zone outward. And this is essentially how these kernels work. So what you're going to have to do in this particular case is you are going to want to repeat this for each of your different variables or each of your different ones. So the passeriformes, and the Psittaciformes, okay? Keep it at 0.01. Make sure to change out your name, otherwise you will write it over, and then we will come back for your zonal statistics.